So let's start with the lecture first. We'll have about 20 minutes for the lecture, and then we'll start the exam. So we started talking about, we actually covered RTP and RTCP. As we said, RTP is used for data plane, and RTCP is used for the control messages. Both of them do not provide any quality of service from the transport layer point of view, but they provide some fields for synchronization and sequencing, which can be used to detect like packet loss and things like that. We started also talking about streaming stored multimedia, and we said that there are two choices for this. We have UDP and we have TCP. So UDP sometimes is used with RTP to provide, again, synchronization and sequencing and so on. TCP is usually used with HTTP from the application layer point of view. And there are some advantages and disadvantages for each of these combinations, whether we're talking about UDP with RTP or whether we're talking about TCP with HTTP. So we'll talk about these two choices or two alternatives for streaming stored multimedia content. So assume that we have a web browser, and the web browser wants to fetch some multimedia content from a server. So one common method for this is to use HTTP, and the simplest approach, which does not have any kind of streaming, is that we have an HTTP GET to the server. So we fetch the multimedia content as we fetch the content for any file. So for us, it's like we are downloading the entire file, so no streaming there. We're downloading the entire file, and then the web browser will feed that file to the media player, and then the media player will start playing that. Of course, the problem with this is the huge amount of delay that we have to wait, right? Because there's no streaming in that case. So we have to wait until the entire file content is actually downloaded, and then it goes to the media player to start playing it. So in that case, there's no streaming at all. In the second option, we have the web browser uses HTTP to HTTP GET to fetch first what we call a meta file. The meta file is a file that contains description about the multimedia content. Okay, it doesn't actually contain anything about. It doesn't contain the content itself, but it contains information about this content, like a description, the encoder type, file names, and so on and so forth. Okay, so that's the meta file. Okay, so that's the first call that the web browser will make to the web server to call HTTP GET to get the meta file, which is then fed to the media player, and then in another call, okay, separate call, the web browser also downloads the content in a form of streaming. Okay, so in that case, HTTP typically uses TCP. Okay, so if you use HTTP, you use underneath TCP, which means that here we are actually using streaming using HTTP over TCP. Okay, we're using the web server in that case for two purposes: as a web server to fetch the meta file, and as a streaming server to fetch the content of the multimedia. So the web server actually is used for both purposes at the same time. So the first issue here is that we are kind of forced to use TCP as the transport layer because that's what HTTP uses. Okay? And as we said, we talked about some issues related to TCP, right? So there is an issue with TCP that the retransmissions will introduce some delay and so on and so forth. So these are issues that we encounter in this scenario, okay, which actually have discouraged many multimedia content providers to use this scenario in the past. But nowadays, because of the development that happened in the network, in the core network itself, okay, the probability of error has become lower, which makes TCP not a really bad option. Okay. The other thing is that as we said, the retransmission introduced some delay, right? And the problem with TCP is that with congestion control, TCP can actually go up and down in terms of transmission rate, right? So this might create a problem at the client side, but if we actually use de-jitter buffer on the client side, we can sort of compensate for this. So that has led the content providers to still use that scenario because of the fact that HTTP is widely available. HTTP actually penetrates any firewalls, okay? So it works very nice with firewalls, with NAT, network address translation. So you can easily say that nothing actually stops HTTP from working, okay? Like for us, when we go outside the university, we cannot access any server in the university except over HTTP. So HTTP goes smoothly through any firewalls and things like that. So that makes HTTP and TCP as an attractive option, and that's why the HTTP over TCP is still used for streaming, even though it's not the best option. Okay, but it's still widely used, and it sort of dominates the internet as the majority for the majority of servers. The third scenario here, which tries to separate between the web server, where the web server actually hosts the multimedia content description, but not the files themselves, okay? And then use a separate streaming server for streaming. So in that case, we use two different servers. One is the web server to fetch the meta file, and the meta file is like any other text file. It's like an XML file which contains information about the video and audio and so on, and which encoder we are using and so on. But it does not host the content. The content is hosted in the streaming server. So why is this separation? Okay, this separation actually allows you to use each server in the most optimized way possible, and also because HTTP is not perfect in terms of streaming, right? The other thing is that here it allows you to use a separate protocol from fetching the meta file or streaming itself. So in other words, here I could use HTTP over TCP, and here I could use RTP over UDP, okay? Or any other protocol combination that can give me the most optimized performance, okay? So I can provide here like different set of protocols that can provide good quality of service and so on, okay? So that's the more common scenario, although the previous one is also very common, and in many cases we use the web server as the streaming server. But in that case, we need another modification to HTTP to be able to work for streaming, because HTTP itself is not very optimized for streaming multimedia content. Okay? So these are the three common scenarios. So as we have discussed before, due to the if we were to assume that the multimedia content on the server side or on the side where we generate the multimedia content is actually fixed in terms of data rate, and the most common example for this is uncompressed audio or video, right? So for uncompressed audio or video, we have this sawtooth kind of behavior that we create packets in a fixed time interval. Okay? So we would hope that this homogeneous packet rate will arrive to the client side exactly in the same way. This will allow us to have almost no buffering at the client side and be able to play out the packets exactly in the same way where they generated. And in that case, we will not have an issue. However, the challenge here is the variable delay that the network introduces. Okay? And as we said, the absolute delay itself is not the problem. The problem is this. The problem is the fact that the packets will arrive at the client side not exactly in the same way that they were generated. Like if the absolute delay is fixed, I don't care. Even if the absolute delay is like 2 seconds, as long as all the packets will encounter exactly 2 seconds. Okay? But that's almost never happens because the network almost always introduces variable delay to the packets. So this creates the effect of jitter or delay variation. So the jitter requires the fact that you have to buffer part of the video, which allows you to wait for a certain period of time for some packets to be buffered at the client side, and then once you start playing out the video, supposedly at every instance of time, you look for the packet in the buffer and you're supposed to find it. Because if you don't find it, then you will have to pause. And the pause usually introduces very bad effect for the person who is watching the video. So we don't want this situation to happen. So that's why we have to adjust this buffering stage using certain buffer size and using certain wait time. So this wait time and the buffer size, they are designed very carefully in such a way that once we start playing out, we are supposed to always find the packets that we play out at any instance of time. We're supposed to find it in the buffer, okay? So that we avoid the situation of pauses. To be able to do this, if we assume that we have like a virtual line here, okay? So we need to draw this same line at some point. If we draw this same line here, okay? This means that for play out, we will wait for this amount of time, okay, to start playing out. The problem with this is that all these packets will have arrived to the buffer except these ones. So we will have a conflict here, okay? So this tells us that this line is premature. So we have to wait for few more milliseconds, which means that it's better to start playing out probably here. Okay? So this line tells us that if we start playing out here, everything that we will play out, we will find it in the buffer. So this actual time has to be calculated very carefully. Okay? And based on this line here, we can calculate the amount of buffer size that we need, the maximum buffer size that we need. Of course, in reality, we can design the buffer size large enough so that we make sure that we store enough number of packets that will allow us to play out with no problems. Okay? So let's